Ever get stuck on a tough problem and someone's like, just sleep on it.
Mm-hmm.
Like your brain needs to really
Yeah.
stew on it for a bit.
Yeah.
Well, what if AI could pull off that same trick?
Interesting.
We're diving into some seriously cool research suggesting we might be on the verge of a major AI learning shift.
It's fascinating stuff. We may be moving away from just building bigger models.
Really?
Yeah, this research is all about making AI more efficient, giving them the ability to really use their existing brain power strategically, especially when they're dealing with super complex tasks.
So instead of just cramming in more information, it's more about teaching AI to think smarter, not just harder.
Exactly. Give them the ability to really chew on a problem, explore different angles, refine their answers. It's kind of like we're making AI problem solving more human-like.
Whoa, that's a really cool concept. And what better way to test out this whole smarter thinking thing than with math problems?
Right. I mean, that's what they did. This study, Snell and the team, 2024, they chose to use really tough, like high school level math problems.
Oh, wow.
Yeah, and these problems, they need more than just knowing the formulas, right? You got to think logically, break it down step by step, and know how to change your strategy depending on the problem.
So how did they actually teach the AI to, like, think longer about these problems?
So they focus on two main strategies. Both of them are about making AI more resourceful at what we call the inference stage. That's the moment when the AI is actually trying to solve the problem.
Okay.
First strategy is all about revisions.
Revision. So the AI is learning to go back and check its work, kind of like we had to do back in school.
Exactly. Instead of just giving one answer, the AI is trained to make a series of responses, with each one building on and improving the one before it.
Huh.
Almost like watching the AI think out loud on paper. You know what I mean? It spots its own mistakes and then corrects them as it goes.
That's wild.
Yeah.
So it's not just random guessing then. The AI is actually learning from those mistakes and then using what it learns in the next try.
Exactly. And that's really important. The data they use for training, it's not just problems and answers. It's put together in a way that shows these patterns of mistakes and how to correct them. So the AI learns to recognize and deal with its own weaknesses.
Wow, that is really cool. But I'm curious, what's to stop the AI from, like, uncorrecting a right answer?
You're thinking ahead. That's a really good question. The researchers definitely thought about that. They had to create special mechanisms, almost like safeguards, to make sure the AI was actually making things better with each revision and not just going down a rabbit hole. They basically help the AI tell the difference between a real improvement and a change that seems right but is actually wrong.
That makes sense. So that's revisions, the first strategy.
Right.
What about the second one? You mentioned something called a verifier, right?
Mm-hmm.
What exactly is that and how does it work with all this?
Think of the verifier as like an internal coach for the AI.
Okay.
While the AI is busy trying to solve the problem, the verifier is working in the background, evaluating every step the AI takes.
So instead of just grading the final answer, this coach is giving feedback during the whole process, right?
Yeah.
Keeping the AI on the right track.
Exactly. Imagine having a tutor looking over your shoulder, giving you little hints, pointing out potential problems before they become big issues. The idea is to give the AI more detailed feedback so it can adjust early on instead of getting to the end and realizing it's gone totally wrong.
That makes a lot of sense. So how do these verifiers actually work? Are there different kinds?
Yeah, there are. The research looks at a bunch of different types of verifiers, and each one has its own way of coaching the AI. But before we get into all of that, let's take a step back and look at the bigger picture here. This is where things get really interesting.
Okay, now you've got me really curious. What's this bigger picture when it comes to these verifiers?
So the really groundbreaking thing here is this idea that, not all problems are the same, right? Like we wouldn't use the same thinking to solve like a simple addition problem as we would to solve some crazy equation.
Yeah.
AI can benefit from the same kind of thing, adapting how it thinks based on how hard the problem is.
That makes a lot of sense. But how do you even start to teach an AI to recognize how hard a problem is?
So this is where it gets really clever. They actually looked at how well the AI did on the problem at first. Like if the AI was already getting a certain type of problem right most of the time right out of the gate, they figured, okay, that problem's kind of easy for this AI.
Okay.
But if the AI was really struggling, then they knew those problems, those need a different strategy.
So they use the AI's own skills as a measuring stick. I like it. But how does that connect back to the verifiers and revisions we talked about?
Because what they realize is that some ways of thinking, Some strategies, they work better for certain types of problems.
Mm,
Like if the AI is dealing with an easy problem, something it's already good at, maybe it just needs a chance to revise its first answer, like we said before.
right, right. If it
Well,
ain't broke, don't fix it. Just a little tweak here and there.
exactly. But for the really tough problems, the ones where the AI gets totally tripped up, that's where these verifiers, these AI coaches, they really come in handy. They can guide the AI, help it through those tricky steps so it doesn't get stuck.
So they're like more hands-on tutors for the really hard stuff.
Exactly. And the research actually tested out different types of these verifiers, some simple, some more complex. And here's the kicker. The more complicated ones weren't always better. It really depended on how hard the problem was.
So you can't just throw the fanciest algorithm at every problem and expect it to work best.
Nope. You got to find the right tool for the job, right?
Right.
The researchers called this compute optimal scaling, basically matching the thinking method to how hard the problem is. And get this, they found out that by doing this, by carefully choosing the right verifier, the AI could actually do better than a model 14 times bigger that wasn't using these techniques.
Hold on. Are you saying that smarter thinking actually beat out just having more computer power?
It seems that way, yeah. And that's huge. If we can teach AI to think more strategically, to adapt its approach,
Yeah.
we might not need as much raw computing power to get the same results. And that has some really big implications.
For sure. Not just for making AI more efficient, but also for making it more accessible. I mean, we always hear about how much energy these huge AI models use.
Absolutely, and that's what makes this research so exciting. It could be a path to AI that's not just more powerful, but also more sustainable. We can make AI that's better for everyone.
So we're not just talking about building bigger and badder AI models here, are we? It's about using what we've got, but in a smarter way.
Yeah, exactly. And that's what's so cool about this research. It's like it challenges that whole idea that more computer power automatically means better results.
Right. Like we're moving beyond just brute force and getting
Mm.
more elegant with our approach.
Exactly. It's like recognizing that AI, just like people, can benefit from different ways of thinking depending on what they're trying to solve.
Which makes me wonder, how far can we push this? If we can make AI 14 times more efficient, what else is possible?
That's the million-dollar question, right? Like, imagine if AI could just look at a problem and know the absolute best way to think about it, and then only use the computing power it actually needs.
No more, no less. That's some next level AI resourcefulness.
And it gets even crazier, this whole idea of compute optimal scaling. It might not just be for AI.
Wait, really?
Mm.
You're saying this could change how we design all kinds of systems?
Absolutely. What if we could apply these same ideas to how we design all sorts of algorithms and systems? Think about saving energy, making processes smoother, even changing entire industries.
So this research isn't just about AI being smarter, it's about rethinking how we solve problems, period.
It's about realizing that efficiency and knowing how to adapt, that's just as important as raw power, you know?
Work smarter, not harder, whether you're a computer or a human.
That's a really powerful idea.
It really is. So as we wrap up this deep dive, what's the one thing you really want our listeners to remember?
The future of AI isn't just about making bigger models. It's about making systems that are adaptable, resourceful, efficient.
Yeah.
Systems that can learn and think more like we do.
That is definitely something to think about. Until next time, everyone, keep those brains buzzing.